So in our class today, are you with me? We are going to start with binomial theorem. Like I said, these are the subtopics that we're going to be learning. I hope you've written this down, or you don't need it. Okay, I actually need it for myself. So let's start. What's the definition of binomial? Right? Meaning or definition of binomial. Right. Binomial is when we have two terms. Binomial is when we have two terms separated by plus or minus sign. Binomial is when we have two terms separated by plus or minus sign and having the power of n. Is when we have two terms separated by plus or minus sign and having the power of n. Now look at what I'm trying to say. For example, now when I say x plus y, the power of what? N. Now looking at the word, two terms, are you seeing that? It can be separated, you can have it as x minus y in the power of n. Two terms separated by plus or minus sign, but the power of what? N. Is that clear? Now for instance, let's look at something like this. If I should have a plus b in the power of 2, is it binomial? Is it binomial? Is it binomial?
Yes.
Okay, why is it binomial? I said two terms. It means 1, 2. Separated by what? Plus or minus sign. Then the power of what? N. This n here can be any value. It can be a fraction. It can be an integer. Are you seeing that? It can be a negative or positive integer, either of the two, either a positive or negative. So I can have it as 2, I can have it as 1 over 2, I can have it as minus 2, either of the two. As far as the power what on it is called binomial. So the issue is that how can we expand binomial? Let's do that fast. Now if we look at this please, let's assume we have a plus b in a power of 0. Who can tell me if I should expand this, what will it turn to? Why is it 1? Because in number system, anytime you have the power of 0, what does it mean? What if I have a plus b in the power of 1? What is it? A plus b. Why is it a plus b? Because the 1 is for this and 1 is for the other one, isn't it? What if I have a plus b in the power of 2? What will be the expansion of this? Let's see how we can do that. We have a plus b in the power of 2. When I separate this, you say a, open everything, a plus b, isn't it? Then plus b, open the other factor, a plus b. Then I have it as a squared plus ab plus ab plus b squared. What's common here? So that will be what? 2ab plus b squared. So that means here is what? A squared first plus 2ab plus b squared. What if I'm given a plus b in the power of 3? How can I expand it? How can I expand that one? You already had the value of what? A plus b all squared. Okay, let me try to explain what I'm trying to say. You know we have a plus b. I want to expand this, and I've already expanded a plus b all squared, isn't it? And what do I have when I expand that one? A squared plus what? Then, so if a plus b squared can give us this, then this can be written as a plus b, then a plus b all squared. Do you agree to this? So definitely, so if a plus b all squared is this, definitely I can say a plus b, then a squared plus 2ab plus b squared, isn't it? Then the same thing I apply, I will say this, open everything, then this, the same thing. So what will I do? I will have A in bracket A square plus 2AB plus B square, isn't it? Then the plus B comes next. Open the bracket A square plus 2AB plus what? Now let's do that. A times A cube. Then A times 2AB. Very good. That means this side that we have A and A, we have to multiply one another. So we have that 2A square B plus A times B, AB square. Thank you. That's AB square, then A square B plus 2AB square plus B cube. Who can tell me what's common? We have A square B and another what? A square B. That's 3 what? A square B. We have AB square, then what? 2AB square. How many is that? So that's A3 plus what? 3A square B plus 3AB square plus what? B cube. Isn't it? So when I expand this, I will have it as what? A in the power of 3, isn't it? Plus 3A square B plus 3AB square plus B cube. Very simple, isn't it? Very simple. I don't understand. Do you have any question? I think this is just the basic. Is there any question? Now, the issue is that, what if I should have, okay, what if, let me rub this side. What if I should have something like A plus B in the power of 4, A plus B in the power of 5, A plus B in the power of 6. Will I still use the same expansion method to do that? No. You can see that. And if you were given this kind of question in your exam, and you are given A plus B in the power of 4, can I still use this method? No. You know why? It's a waste of time. That is why binomial theorem will help you, not for you to pass through all this process. Are you seeing that? It will help you to find a way you can expand this thing without doing this stuff. So let's see it. That's why we have what we call Pascal triangle. Everybody write Pascal triangle. I'm going to rub this side. Pascal triangle. Pascal. Now, what does Pascal triangle says? Pascal triangle says every term will always start with 1. And again, and every term will always end with 1. Again, every term start with what? And end with what? So that means I can have 1. You can see, starting with 1. At this side, start with 1, end with 1. Can you see that? Start with 1, end with 1. I'm doing something. Start with 1, end with 1. Let's do one more. Start with 1, end with 1. Now the question is, how does it form the triangle? The way the triangle is being formed. Start with 1, isn't it? Now, start with 1, end with 1, isn't it? Now this one that has 1 at the beginning, 1 at the end. When you add it up together, what will it give you? The 2 be at the middle. This one that has 1 and 2, what will it give you here? 3. 2 and 1, what will it give you? 3. Can you see that? 1 and 3, what does it give you? 3 and 3, what does it give you? 3 and 1, what does it give you? Imagine I have one more. This 1 and 4 give me 4 and 6 give me 6 and 4, 4 and 1. Then the question is, how does the triangle form? Now is it a triangle? It's not forming a triangle. It's not forming a triangle. It's not forming a triangle. So that triangle telling you that if you add this and this together, you get the middle. Add this and this together, you get the what? Add this and this together, you get the what? That's what we call Pascal triangle. Now the question is, what is the usefulness of the Pascal triangle? Why is it useful? Remember the other time when I was expanding A plus B in the power of 3. What's our result? A in the power of 3, isn't it? 3A square B 3ab squared plus what? B in the power of 3. Now look at this carefully. The first number at the top is called n equals to 0. The second one is n equals to 1. The third one, n equals to n equals to n equals to n equals to. When my n, which is here, is 3, where will I have it? Now look at it. Look at the coefficient of a in the power of 3. What is it? Coefficient of this. The coefficient of this. The coefficient of this. So that means that can also help us to get this. So what is the power of this? 4, isn't it? So what will be the coefficient? 1 first, 1 come first, 1, then 4, then 1. So it has helped us to get our coefficient. The next thing to do is to get our variables. What are the variables? These are the terms, A and B. So in getting the variables or in getting the terms, the first term will start with the power, then decrease. The other term will start from the bottom, then increase. What do I mean? If here is A here will be A in the power of 4, while B here will be B in the power of 0. So because A is in the power of 4, when it's coming to the next term, it's going to turn to what? A in the power of 3, then what? A in the power of 1, then A in the power of what? So let's write it out. Yes, A in the power of what? 3. A in the power of what? A in the power of what? A in the power of what? Now, B is the power of 0. As B is crossing the term, it's going to increase. So B in the power of 0. Now, know something. Let's write it again. Do I need to write 1? Anything in the power of 0 is what? 1 times 1. A in the power of, we are good. Plus, what will I have here? 4A in the power of 3B. Next one, 6A squared B squared. 4AB in the power of 3, then B in the power of 4. This is how you expand it. Very, very simple. Okay, everyone, let's try one more. Write this fast and let's try one more. Okay, let's try this one, please. Let's try this one. No time. I want to expand this. And the power here is what? A in the power of 5. Where do I have A in the power of 5? N in the power of 5 rather. Where do I have it? This. So the first thing is to write the what? Coefficients. What are the coefficients, everybody? 1, 5, 10, 10, 5, and 1. The next thing is the what? The terms. Starting with what? A in the power of 5, then B in the power of 0. A in the power of 4, then in the power of 1. A in the power of 3, B in the power of, A in the power of 2, B in the power of, A in the power of, B in the power of, A in the power of, B in the power of 5. Now, let's write it in the proper way. Now we have it as A in the power of 5 plus 5 A in the power of 4 B plus 10 A in the power of 3 B squared plus 5 A in the power of B in the power of 4. Then at this side plus B in the power of 5. This is how you expand this. So I want everyone to try A plus B in the power of 6. Try A plus B in the power of 6. What? 10 A in the power of the 20 minutes. So we have A plus B in the power of what? 6. The first thing, at this side we have it as 1 and 5, isn't it? So when I have it here, adding this together will turn to what? 6, 15, 20, 15, 6, then 1. So the power are coefficients rather 1, 6, 15, 20, 15, 6, and 1. Then what happened to the coefficients, or sorry, the variables rather? A in the power of 6, b in the power of 0, plus the other one, 5, b in the power of 1, plus a in the power of 4, power of 2, plus a in the power of 3, b in the power of 3, plus a in the power of 2, b in the power of 4, plus a in the power of 1, b in the power of 5, plus a in the power of 0, b in the power of 6. Then I have it as a in the power of 6 plus 6a in the power of 5b plus 15a in the power of 4b squared plus 20a in the power of 3 plus 15 a in the power of 2 b in the power of 4. Let's come here. Plus 6a in the power of b in the power of 5. Then b in the power of 6. That's how you expand this. Sample problem 1. Sample problem 1. A question from your exam question. It says, determine using Pascal triangle method. Determine using Pascal triangle method the expansion of two p minus 3q in the power of 5. 2p minus 3q in the power of 5. So we have to use Pascal triangle method to expand this. Determine using Pascal triangle method the expansion of 2p minus 3q in the power of 5. Solution, everybody. Now the first thing is, now listen to me carefully. You solve question based on the rules. Hallelujah. Solve them based on what? Instruction. They said using what? I mean, they expected you to do what? Draw it. Is that clear? I know most of you must have memorized the power of 5. 1, 5, 10, 10, 5, 1, isn't it? But if you do that, you're right. But according to the instruction, we have to use what? Pascal triangle. Is that clear? So let's do it. Pascal triangle, what do we have? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. When the power is 0, when the power is 1, when the power is 2, when the power is 3, when the power is 4, and when the power is 5. So according to the question, we want to expand this when the power is what? 5. Where are my coefficients? These are the coefficients. Coming here, everyone pay attention please. We have 2p minus 3q in the power of 5. The first thing you need to do is that always ensure that the middle sign is always plus. That means, can I write this like this? 2p plus minus 3q in the power of 5. Yes. Because on the long run, plus and minus will be what? When you've done that, assume that A is 2p, then B is minus 3q. In that case, I'll now say A plus B in the power of 5. So when you do that, you first expand this by using the Pascal triangle. Let's do that fast. A in the power of 5 plus 5a in the power of 4b plus 10a in the power of 3 plus 10a in the power of 2 B3 plus 5A in the power of 1, then B in the power of 4 plus B in the power of 5. Don't worry, I've actually taught you how you can get these numbers, isn't it? Yes. And I've also taught you how this thing can increase and decrease, isn't it? Yes. Immediately you've expanded it, we place back what? The value of A, which is 2P. We place back the value of what? B, which is minus 3Q. Now we're placing that. Now my A at that side is what? 2P. So here is 2P in the power of 5 plus 5. Then A is again 2P in the power of 4. Then what's my Q? Minus 3Q. The next one, 10. Is it minus 10? Calm down. Let's start with that first. Plus 10. Then A is what? 2P in the power of 3. Then minus 3Q in the power of 2. The next one, 10. 2P in the power of 2. Then minus 3Q in the power of 3. The next one, 5. A, 2P in the power of, then minus 3Q in the power of, then we now have plus minus 3Q in the power of. At this junction, there are a lot of error because many students usually make mistake by the sign. By the what? Where do we have our minus sign? Here. Isn't it? At this side, this 5 affect the 2 and also the what? P. And that give me what? 32P. That is done, isn't it? Now this side, this my minus. First affect this plus. Then make it what? Minus. Then after you've done that, go for the power immediately. 2 in the power of 4, 16. Then the 16 multiplied by 3. You can use your calculator now, please. That's 48. 48 times the coefficient, which is 5. You can see the way I'm doing it one after the other. 48 times 5, please. 240. That's 240. Then P in the power of 4Q. Is that clear? Now, the next thing to do, coming to the next term, consider the sign first. Here is what? Minus. Calm down. The sign first. Here is what? Minus. When you say minus square, meaning minus times minus, that's plus. So the plus that is gotten from here, multiplied by the plus here. What do we have? Plus. It's very important. Then after you've done that, go for the power next. 2 in the power of 3 is what? 8. 3 in the power of 2 is what? 8 times 9, 70 what? 8 times 9? 72. So 72 times 10? So 720 money. Then P in the power of 3, Q in the power of what? Now let me tell you a logic. A logic is that anytime you are given a negative sign and the power on the negative sign is an odd number, automatically it is negative. Again, coming again. What number is this? 3. Is it odd or even? If the power is odd, it means that the power will be what? Negative. What's there? 4. Odd or even? If the power is even, it means it will be what? Positive. Now I see here was even number. What do we have? Positive. Here was odd because it's 1. What do we have? Negative. Who can tell me what will be the, is it negative or positive now? Negative. Very good. You are learning well. So what do you expect here? A negative sign. So minus times plus. The minus is there. Then go for the powers next. 2 in the power of 2 is what? So 3 in the power of 3 is what? So 27 times 4. Then multiply by 10. 1080 P square Q in the power of 3. Look at what will be the power, the negative sign? Plus. So plus times plus is plus. Then, 3 in the power of 4, 81. 81 times 2 times 5, 810. P Q 4. Then who can tell what will be the sign here? So here is minus. Then 3 in the power of 5. Then 243 Q in the power of 5. This is how you expand it. Very simple. I don't understand how we do this. Binomial expansion. Rules of binomial expansion. I'll be dictating the rules, please. I will need you to write. The first rule: determine the coefficient. Determine the coefficient using Pascal triangle or combination series. That's the first rule. Second rule is that the first term decreases. The first term decreases from the power, while the other term increases to the power. The other term increases to the power. The third rule says the total number of terms, the total number of terms is equals to n plus 1. Rule 5. Rule 4. The first and last term must start with the coefficient of 1. Rule 5. The second term and second to the last term must start with the coefficient of nth term. And lastly, the sum of the power of the variables must be equal to the nth term. So the reason why I'm giving this rule is that imagine I expanded a binomial expansion, and I want to know whether my answer is correct or not. How will I know? Pay attention. What's the first thing, everybody? So this combination series, I'm going to explain that in our class very soon. So when I've gotten that, the coefficient first, then what was the next thing? From the power. Sorry, I didn't put that. From the power and very good. Thank you. So what did I do here? Look at it. When I first determine the coefficient, where is it? 1, 5, 10, 10, then 5, then 1. That's the first thing. Then I said the first term, which is my what? Hey, decreases from the power. The power is 5. So 5. So start decreasing. To 4, 3, 2, 1, and 0. The other term, which is B, increases to the power. Isn't it? Very good. Now look at this. This one are very important. They call them cross-checking. It helps you to cross-check your work when you perform these things. Now what does this say? The total number of terms is equals to what? N plus 1. Now I have the other time as what? My n is what? 5. So when I say n plus 1, that's what? So therefore, this binomial expansion should have how many terms in total? 6. Let's look at it. Is it 6? This is 1. This is what? 2, 3, 4, 5. If I don't have up to 6, or I have more than 6, it is wrong. Is that clear? So if it is 5, it is wrong. If it is 4, it is wrong. It means that the answer is wrong. I must ensure that the terms are greater than the what? By. Good. That's that. The other one is what? The first and the last term must start with the coefficient of, if you look at it carefully, 1. Okay, for this case, that's not it. For here, 1, then what? What else again? The second term and second to the last. Where is my second term? This is my second term, isn't it? Where is second to the last? Second term and second to the last term must start with the coefficient of the n term. What's the n term? 5. So I think it was 6. What will be here? 6 and 6. I think it was 7. What will be here? 7 and 7. That's balance. Then lastly, the sum of the power of the variable must be equal to the n term. If you look at this carefully, I hope you know that I have q here to the power of 0. 5 plus 0 is equal to the power, isn't it? What's here, everybody? 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4. I think there's p, q in the power of 5. Have you seen that? So when you add the variables together, it must be what? Equals to 5. This is the way we cross-check a binomial expansion. Is that clear? Should we go further? Let's go. Binomial series, right? Binomial series. Binomial series.